Alright, so we're going to look at this first problem here, and what we notice is that we have some sort of object hung stationary from two different massless strings. They're labeled as T1 and T2, and we'll notice that they each have corresponding angles associated with them that aren't labeled, but we can kind of see them. I'll call that theta 1, and I'll call this one over here theta 2. To kind of label them. Now, what you'll notice here is that this rope is hanging at a much steeper angle than this rope. So this angle, theta 1, is larger than the second angle. So I'm going to label that here. Theta 1 is greater than theta 2. So this is a steeper angle than that. Okay, the next thing I'm going to think is, well, this is a tension force at an angle, right? They both are, and you could think of them in their separate components if you want. But what the question says is that the magnitudes of the tensions T1 and T2 in the strings must satisfy which of the following relations. So the magnitudes of the tension. Okay, now what it's basically asking us is what's happening with the overall tension forces on these two strings. And yeah, you could think about them separately. And we'll talk about that in a second when we go through all these answers. But what it's asking about is the overall tension force, what you can think of as like the hypotenuse, right, when we break them up into their components. So it's asking us to compare their overall tension values. Alright, so let's go through some of these answer choices. And there's three of them I'm really going to highlight, and that's A, C, and D. Now most of you probably put A or D here, and let's talk about those. Well, if this object is hanging motionless, right, if it's stationary, we should understand that the forces acting on this object must cancel out, right? There's no net force acting on this object. So let's draw a free body diagram for this, and let's think about that, right? So we have our object here, and obviously we're on Earth, right? So there's going to be a force of gravity acting on the object, okay, which is equal to mass times the acceleration due to gravity. And we have these two diagonal forces. Now let's think about their components here. Well, the object isn't moving left or right at all, okay? So the forces acting left and right on this object must cancel out. Now, the only forces pulling to the left or to the right, horizontally on this object, are the two tension forces, and specifically the horizontal component of those tension forces. So if I break up T2 here, I get, let's call it T2x, right, the x component of that. That must be equal to T1's x component, right? These two forces must cancel out in order for this object to not be accelerating to the left or to the right at all. Now that just leaves the upward parts, right, the vertical components of these two tension forces. Well, we know that the vertical components of these two tension forces have to cancel out the weight of this object, right? They have to add up to equal the weight of this object. However, that does not mean that the vertical components of these two forces are equal to each other. Okay? And it turns out they are not. And the reason is because the angle here is greater than the angle here, right? More of this rope's tension force is vertical. Right? Look at it. I mean, it's just more vertical. So more of its overall force, of its tension force, the magnitude of its tension force, would be pointed vertically. Okay. So I'm going to label that T2y. And now what I'm basically saying here is the y component of this tension force must be greater than the y component of this tension force because its angle is greater. In order to find that y value, right, you use sine. And if you're doing sine of a greater angle, you're going to get a greater answer. I mean, plug it in. I mean, just test some values. Plug in an angle for that, plug in an angle for that that's smaller. you'll see it mathematically. It has to be true. So this T2 must have a greater Y tension force, right, Y component, than T1. And the two of them must add together to equal the weight. I'll call that T1Y. Okay? So let's go down the line of these answer choices and let's think this through. Okay, so what it's asking us is the magnitude of the tension. So the overall tension, right? Both components together compared to the overall tension of T1. So the first one is T1 is equal to T2. That's what A is saying. And if it was asking about the horizontal components here, I would agree, right? Because the horizontal component of T1 is equal to the horizontal component of T2. But the vertical components are not. So once again, since T2 is at a steeper angle, since most of its tension is pointing vertically, then it has a greater vertical tension force than T1. So A, even though many of you chose that, cannot be true. And I understand why you chose that, because the horizontal values must be equal. But overall, the overall magnitude of the tension forces are not equal. Answer choice B says T1 is greater than T2. And once again, we clearly see that that's not true. T1 and T2 have equal horizontal components, but unequal vertical components due to the difference in their angles. So T2 overall must be bigger than T1. So B cannot be correct. C is looking pretty good here. T1 is smaller than T2. We basically can see that it is, so it's probably the right answer, but let's go down the line here. T1 plus T2 is equal to the weight. And once again, if it was asking about the vertical part of the tension, I would agree, right? Because the vertical components pointing upwards have to be equal to the vertical components pointing downwards in order for this object to not be accelerating up or down. So vertically, yes, this is true. But once again, the question is asking us about the overall magnitude of tensions T1 and T2. So this would be true if we're talking about the Y values, but however, we're talking about the overall forces. So that can't be true. And then this one definitely does not make sense. T1 minus T2 is equal to mg. Absolutely not, right? If I subtracted these two, I'd get a much smaller value than the force of gravity. So that's not true. The answer choice has to be